This video is on net ionic reactions and net ionic equations. So net ionic equation is an equation for a reaction in solution that only shows the parts that make a precipitate. A precipitate is the solid that is formed in this reaction. So all these reactions happen in aqueous states. There's two aqueous compounds reacting together to make either two aqueous compounds or an aqueous compound and a solid compound, and that solid is your precipitate. There's some different steps we need to follow when making and determining our net ionic reactions and equations. First, we want to write out our reaction. Then we want to check the solubilities of all of our compounds. Notice that our reactants are always soluble because our reactants have to be soluble to be dissolved in the water of the two liquids that we're going to pour together and react together. And I'll do a demonstration of this in class tomorrow. Then we're going to circle the solid precipitate that we make. And then we'll write our solid equation backwards, starting by writing our solid, then the arrow, and then determining what two things we needed to make that solid. All ions that are not used in writing my final equation for my solid are considered spectator ions. So let's go through an example. I have silver nitrate and sodium iodide. I need to then finish my reaction. Step 1, write out reaction. This is a double replacement reaction, so my silver and my sodium are going to switch places. So I then have silver iodide plus sodium nitrate. Okay. Then I go ahead. Step 2 says check the solubilities. Reactants are always soluble. So that means that my reactants of silver 1 nitrate is aqueous, as is my other reactant of sodium iodide. And they get the little AQ under them, showing that they're aqueous. Next, I go ahead and check my solubilities of my two reactants. I find that silver iodide is insoluble, which means that it is going to be a solid or precipitate. So after that, I write S for solid. Sodium nitrate, I find is going to be soluble, meaning that it dissolves, dissociates completely in solution, so that's aqueous, AQ. Next, I go ahead and I circle my solid. My solid that I've made is silver iodide. Then I write my solid equation backwards. So I draw my arrow, and I write my solid I've made, silver iodide, solid, and I write the two things that I use to make it. This is like writing a decomposition reaction, except in a backwards format, or creating a synthesis reaction. Well, I had silver and iodine. They had to react, and the ions were in solution reacting together. So I had silver plus 1, aqueous, which are my ions, plus my iodine minus 1, aqueous, ions, reacted together to make my silver iodide. So again, I show both my elements, but they're not the elements reacting together. It's not silver solid and iodine solid reacting together. It's silver ions that were dissolved from my silver nitrate, and my iodine ions that were dissolved from my sodium nitrate have reacted together to make my silver iodide solid. Go ahead now and try doing the net ionic equation for the reaction between sodium carbonate and barium nitrate. First, you should have wrote your reaction. You have sodium carbonate plus barium nitrate reacts together. Double replacement, so my sodium and barium switch places. So I now have sodium nitrate plus barium carbonate. And now I check my solubilities. My solubility of my two reactants are always aqueous. My solubility of all nitrates is aqueous. And my solubility of carbonate is insoluble. So this is going to be my precipitate, or my solid. I then circle my solid. And I write my solid equation backwards. So I draw my arrow. I show that I'm making barium carbonate solid. And I'm making this from my barium ions and my carbonate ions. So I have barium, which is +2 because it's in group 2, and that's in its aqueous form, plus my carbonate, just CO3 minus 2, also in its aqueous form, are coming together in my water solution, my aqueous solution, to make barium carbonate. You can think of it as having a little beaker here with all my ions floating around, of my sodium ions, my carbonate ions, my barium ions, and my nitrate ions. They're all floating around in the solution, and just so happens that my barium, when it meets my carbonate, they form together. My barium donates its 2 electrons to its carbonate here, and it makes a solid, which then sinks to the bottom. Everybody else, my sodium ions and my nitrate ions, continue floating about in solution in an aqueous environment.